sure some folks in the audience are feeling like they walked into an episode of Mystery Science Theater 3000 at this point. So I'll try to keep this high level and just highlight some issues that are outstanding right now, and per instructions try to keep it fairly neutral. And with Dr. Ashji's permission, I hope I borrowed one of his slides, and he borrowed it from John Deere with acknowledgement, so I feel okay borrowing it back. I think one thing in terms, I think it would be very helpful to put Dr. Ashji's very detailed and informative presentation, very helpful presentation in context, is to ask, what problem is Dr. Ashji trying to solve? And I think Scott from Garmin indicated that there are different issues with other kinds of GPS receivers. So a general navigation device like you have in your car tends to be a small integrated unit. And as Scott said, you can't break that apart, put new equipment in it, and give it back. It's a highly integrated device where form factor is really important. A precision receiver, which is the kind that Trimble makes and sells, the kind that Dr. Ashji makes and sells, is a bigger device that is a little more forgiving form factor for retrofit options, but it's not an unlimited freedom to implement retrofit. And so I think this is all an outgrowth of, I think what Dr. Ashji is trying to do is explain what a possible solution for precision receivers are. As Scott said, that solution is not necessarily applicable for general navigation devices. I'm going to have to go away from the mic just to use this chart and kind of show you. Hopefully people can hear me. I'll try to talk loud. So this chart actually highlights a critical issue with respect to high precision receivers, because you've heard a lot of discussion in the press about, can anyone hear me fairly well?
Let's turn it on.
They're recording it though.
Okay. Oh, this should work. Okay. Hello? Yes. So with respect to high precision receivers, you've heard a lot about filters and cheap filters and various things like that. Call your attention to a few things in this chart. Again, this is GPS signal power here. This is the transmission power of the previously authorized satellite use of the MSS band. So the band that LightSquared is licensed to have is MSS. It stands for Mobile Satellite Service. Note the satellite. These red bumps here are LightSquared's operating power in terrestrial mode. Now, as General Counsel of Trimble, Dr. Ashji used the word monopoly. I'm sure he didn't mean it in the U.S. antitrust sense, but I'll just clarify something. What precision receivers have been designed to use are these GPS signals, which are transmitted here. And they've also been designed to use signals like this that are transmitted in the MSS band by people, including LightSquared. So this was LightSquared's primary business before the new terrestrial business model. And when you talk about filtering, I think you've figured out, hopefully from Dr. Ashji's presentation, a key thing about how well you can reject or turn away power in this band is where is this filter, where does that drop? And so what Dr. Ashji just presented was an implementation in which the filter drops right about there. Right now, this is, I believe this is Dr. Javad's filter. You'll see it's open to energy all the way into here. You'll see current precision receivers, the filter is open to energy and then drops off there. So one of the ways to solve the problem for precision receivers is to filter starting here. Now, the reason why precision receivers didn't filter there before is because they used these satellite signals that were offered for money by LightSquared, and they're still offered today. So implementing what Dr. Ashji proposes, which is to filter here, is a way to dramatically improve the interference rejection of high precision receivers. There's no doubt about it. Why didn't high precision manufacturers do that before? Because their contracts with MSS providers said that their receivers that wanted to get this signal needed to be able to receive signals anywhere in this band,
because under international coordination treaties, they could transmit those signals anywhere in the span. So he shows them here, but they could have transmitted them anywhere here. So this is a lot of why we have this problem right now. Because these filters are not designed to filter out all this energy in here, it causes massive interference. Even the lower 10 causes massive interference to precision. There's no doubt about that, no argument. Well, all the test results show it. So all manufacturers, if they know that those low power signals are going to be here, can design filters just like Javad's that cut off there. And their performance will improve greatly. They will reject interference to a much greater degree. The question is it good enough? Is it good enough? That's what the FCC and NTIA have asked to test. We are cooperating in those tests. We welcome the input from Dr. Ashji, and we welcome all input on possible solutions, and we seriously consider them, notwithstanding, I think, some of the rhetoric going around. I think a second kind of unresolved issue, which is critical, and I'll just highlight it, per my promise to Tom, I won't go into an extensive debate about it, but that is cost. So any solution involves one of two things. Either retrofitting a high precision receiver, which is, a pretty expensive device, $10,000, $20,000, $30,000, retrofitting that, and, the cost estimates I think that Dr. Ashji put in the record at the FCC are somewhere between $300 to $800 for his receivers to retrofit those. If it's outright replacement, then we're talking, potentially tens of thousands of dollars. And the further question then is, if in order to accommodate operations in the lower band, we need to replace or retrofit those, who should pay? Obviously, the industry's position is that LightSquared, as the new entrant, should pay those costs. And that's typically what the FCC does. When a new entrant shows up, wants to make a new spectrum use, and it impacts people previously in the band, they pay. That's a cost of doing business. It makes sure that the full economic costs of a new service are borne by that new service and not by some other industry that's been happily doing their business in the past until the rules changed. So that is a very big issue for us. The costs are potentially, as I said, with 750,000 to 1 million receivers, those costs are potentially high hundreds of millions, more than $1 billion, just for commercial receivers that are out there. And that doesn't include all the expenses of long certification, very testing intensive applications like aviation, which Scott mentioned, defense applications, which General Shelton mentioned in some recent testimony. Not to mention all the costs of then integrating the new equipment and making sure it works with all the systems that it's embedded in. And those costs are quite substantial. There's also potentially foregone costs or foregone savings and those sorts of things. And the coalition's put together some figures which we are happy to make available. So this is what we're talking about. Number one, how do we solve interference using the lower 10, general navigation devices and cell phones? There are hundreds of millions of those. What Dr. Ashji's talking about is how do we solve interference to precision receivers? The answer there is yes, there may be new technology which we need to test, which I think all the manufacturers are working on. We need to test to make sure it works so that equipment will function just as well. And then when we need to retrofit and replace, who pays? So I think those are critical issues. I think another related issue here is what did the FCC authorize before? And that's been kind of extensively documented on the record. Our position is that the FCC authorized terrestrial use of this band only for limited fill-in purposes, not ubiquitous terrestrial-only services like LightSquared is proposing now. But again, those issues have all been addressed in detail. Read the decisions, read our summaries of them, judge for yourself. And thank you so much for listening today.